Alright, so these are going to be our notes for Unit 8. First one here, with this one the big idea is if you have not done Unit 6 yet, or if you need a review on graphing, I encourage you to go back and watch some of that Unit 6 video, and then work through all of number 1. So you're going to do all of these problems here on 1. What that'll give you to do is a good refresher on, again, just graphing a single linear equation. From there, we'll move on. Alright, solving systems by graphing. This is 2. So, we're going to kind of skip over a bit of the ideas here. Kind of the big idea is the 3 different outcomes. One solution. So in one solution, we have some lines that intersect each other at exactly one point. Here our solution is an ordered pair, x comma y. No solution means I have 2 lines that no matter how far I go on, they never touch one another. These are parallel lines. And our last one, infinite solutions, is when I have 2 lines, but in reality, they're the same line. So here the equations might look different, but the lines are exactly the same. So these are the same line. Alright, you guys are going to love this. When we solve these, we are using GeoGebra. So anytime you solve by graphing, we're only going to use GeoGebra. So go ahead and open that up now. So, once we go ahead and solve, here's what we're going to do. So we want to have y is equal to 2x, or negative 2x plus 3. So for my first equation, I'm going to go ahead and type that in. So in the input, y equals negative 2x plus 3. Once you've done that, press enter. You'll see a graph of your line as well as the line named over here. For our next equation, we have 2x plus y is equal to 3. So let's go ahead and type that one in, just like it looks. Here, we graph as well. Now, what we're going to notice here is that these are in fact the exact same line. We see our f and g overlapping, so since they're the exact same line, they just look different. Our answer here is going to be infinite solutions. For our next one, we have y equals 1 and y equals negative x minus 3. So let's go ahead. We're going to delete what we have. So I'm just going to click on them, right click, delete, right click, delete. Definitely clear them out each time. So for our input here, we're going to type in those equations. So my first one is y is equal to 1. So up here, y equals 1. Press enter. It draws our line in. Our next equation, y is equal to negative x minus 3. Y equals negative x minus 3. So, if I want to see where these intersected at, I'm looking here. So it looks like they're intersecting at negative 4, and then halfway between 0 and 2, which is 1. So their intersection is negative 4, comma 1. You can use that exact same method to solve all of these problems. So anytime you're asked to solve by graphing, easiest way, use GeoGebra. So what I'd like you to do is complete these next 2 problems. And once you've done that, complete all the problems here on practice 3. Again, we are just using GeoGebra for all 10 of these. So no need to actually show the graph, just use GeoGebra, identify your answer. From here, once you've completed that, we're going to move on to 4. We're actually going to skip over this. I don't really like how the page was formatted, so I'm going to do a couple problems on your homework for you. So here we're using substitution. So on this one, the concept is we're going to plug something in for something else. So together we're going to do problems 1 and 10, and the left will be left as practice. Check something. All good. Alright. So, for this one, this is an example example where we have 2 y equals. So I'm given y equals in both problems. So in this case, we're going to set these two sides equal to one another. So I would have negative 4x plus 7 and negative 5x plus 9, and they're equal to one another. Now, we're going to solve for x. So let's move my x to the left, just like we've done before. So I find out x is equal to 2. Now, to get my solution for y, that other part of the ordered pair, I can use either equation. So I'm just going to use the top one. So I know that y is equal to negative 4x plus 7. And to solve for y, I'm going to plug that 2 in for my x. Calculator here gives me negative 1. So the final answer, which I'm looking for here, is 2 comma negative 1. Now, let's take a look at number 10. Here, if we look, we have, let's see how I name this, 1 y equals. So I only have one equation where it's already y equals. So in this scenario, we're going to use a little bit of a different type of substitution. So first, put parentheses around the equation with the y equals. Now what we're going to do, and this is similar if I had x equals, it's the same thing. So since it's y equals, we're going to plug in to the other equation's y. So that entire term that I've written here in red with the parentheses goes here. So what that gives me is negative 6x minus 3 parenthesis negative 2x plus 8 equals negative 6. Now, once we've substituted, we can solve. So first, I'm going to distribute that negative 3 to everything inside my parentheses. Again, if you're looking for a review on distribution and solving equations like this, the best place to go is going to be that Unit 2 video. Same side of the line, we're going to combine these two terms. So here, negative 6 plus 6, well, that gives me 0x minus 24 equals negative 6. 0 multiplied by anything goes away. So this gives me negative 24 is equal to negative 6. Is that true? That's a false statement. So what that means, since I got to a false statement, there's actually going to be no solution here. Similar to what we did back in Unit 2, is let's say I arrived at a true statement. So if I got something like 5 is equal to 5, well that's true. So that would be how we'd find infinite solutions. Let's go ahead and do one more together. So let's try number 12. So here, if I'm looking for my y equals, this is another 1 y equals. So that's there. So I'm going to plug it into this y. So I'm leaving everything around it the same and putting those parentheses. So 3 parentheses x minus 1 equals 9. From here, as I've said, we distribute first. So I'm not doing anything with the negative 7x plus 3x minus 3 is 9. We can combine these two terms here because they're like terms and on the same side. So same side of the line, just combine. Let's add 3 to both sides. So I have negative 4x plus 12, divide. So I'd get x is equal to negative 3. Now, when you're plugging back in, you can use either equation, but I would suggest using this one since it's already solved for y. It gives me a little bit less work. So I have y equals x minus 1, and if I plug in that negative 3, so always plug in with parentheses, calculator, y is negative 4. So our solution that I'd be looking for is x, comma, y. Alright, from there, what you're going to work on now is finishing all the problems on this page. Make sure you take your time and show all steps as I have. You'll also be working on substitution here. You'll notice the first chunk of these, 1 through 5, we have y equals. So in the 1 through 5, we have 1 y equals. So let's do a quick bit of examples here when we don't have that scenario. So, actually it's 1 through 6, my apologies. So 1 through 6 should look pretty familiar. We have 1 y equals. Now, some other problems here, we move on a bit. So, first thing we're going to do for each of these problems is identify a special term. So by special I mean, it's a variable with a coefficient of 1. So here, if I'm looking, well that's a coefficient of -4, that's -5, this is -1. But here, this is a coefficient of +1. We'll see why that makes sense after we identify it. Looking here, well, it's -7, that's -2, but this one is just an x, so it's a coefficient of just 1. Let's see, -5, -3, 6, well, here it is, there's my one with just a coefficient of 1, or just x, or just y, positive. 10, we would use this one, that's just a positive y. 11, 3, -3, well, here it is. It's just x, or just a positive 1x. 12, upon examination, we find it's here, at that positive y. 13, well, this is a negative x, so we don't want to use that, but there's a positive y. And 14, again, our positive y. 15, then we get a y. 16, another y. It doesn't matter if it's y or x. And we'll skip this last bit of problems here. You'll also notice at the bottom of this page there is an answer key to check all your answers. So just make sure you're showing your work. Alright, so let's do number 7 together. So, first thing, to use that substitution, I got to get y by itself. So to do that, I would take this -4x plus y equals 6. I want to move my x over. So I'm going to add 4x to each side. So that gives me y equals 4x, because it's positive, plus 6. Now I can substitute, just like we've done before. So I'm plugging that into my other equation. From here, I need to distribute that negative, so it's like having a -1. So it'd be -5x. And again, for more notes on this, go back to reference the Unit 2 video. Same side, we're going to combine. Divide. I get x is equal to -3. Let's go ahead now. We do have an equation up here solved for y, so let's plug in there to find our y. You could also plug into those other two equations, but this one will make it a bit simpler. So I'm plugging in that -3 for my x. Calculator here, we'll get y as -6. So our solution, -3, -6. We'll also do 8 together, because this one's solved for x. So here, x was my special variable with that coefficient of 1. So what I'm going to do is solve this equation for my x. So to do that, I'm going to add 2y to both sides. So that would give me x equals 2y plus 11. So that, I'm going to substitute, but this time I'm going to plug it in for x, because that's the variable by itself. So here, I'd have -7 parenthesis, 2y plus 11 minus 2y equal -13. Solving, so we're going to distribute again. Again, Unit 2 video. Now, even though they're not next to each other, they're still on the same side of the line, so I'm just going to combine those like terms here and here. Dividing gives me y equals -4. to get my final answer, this time we got y first. So I'm going to plug that y back in here to my x equals equation to figure out what x is. So here I get x is equal to 3. So my solution, x always comes first, so 3 comma my y of negative 4. At this point, you should be good to finish all the problems up to this page, besides the ones I've crossed out at the bottom. Once you do that, we can go ahead and move on to 8 for some more notes on a little bit of a different method of solving. Okay, so for 8, we're actually going to skip over it and we're just going to go right into homework, just again give you guys a little bit less work here. So let's go on to 9 and do some of these together. Now, talking about kind of similarity between problems, we're going to talk about which chunks of this homework are going to have similar strategies. So for numbers 1 through, let's see here, 4. That's going to be one chunk that's kind of the same. Let's see, now our next chunk here, number 5 through 8, those will be similar. Give me a moment here. You know, we'll just work through 12. But those will be similar as well. Alright. So we're going to do problem 1, 5, and 9 together. And again, this practice will conclude here. You are welcome to do the next chunk, as it is great extra practice. You'll notice that there is an answer key following at the bottom. However, these would be the ones I would check in for you to advance on. Alright, so how to tell when to use elimination? We'll notice here that neither of these equations is solved for y. So the key idea of when we should use elimination is when no equations are solved for y. Otherwise, if we have something solved for y, we've seen substitution is pretty quick. So, the key idea here is we're going to have this type of setup. So something x plus something y equals a number. Something x plus something y equals a number. What we want to do is find some leading terms here. So if I called this a, let's just say it's some number. Let's just go with the nice hashtag here for the number symbol. So let's say I want to cancel my x's. Then I would want this number out front to be the same as this one, but I want one of them to be negative. So maybe the top is negative, or maybe the bottom is negative. It doesn't matter, as long as they're the same number, but one positive and one negative. Similarly, if I want to cancel my y's out, I would have the same number, and maybe the top one's negative this time, or the bottom. Again, it doesn't matter. Notice, when we're doing this, we only need to cancel one variable, either x or y. It has nothing to do with these numbers. So, for our first one here, let's look at my x's. We see that they're the same number, and one's negative and one's positive. So that means I'm going to cancel my x's. If I looked at my y's, well, those are different numbers. Can't cancel them. So in this first chunk of examples, these are the kind of setup where there's already something to cancel. So here, since these are the same, we're going to think about adding, and we're going to add down. So negative 4x plus 4x, well, that's 0x. But we know that multiplying by 0 just eliminates the term, so it's gone. So these terms cancel. Adding down, negative 2 plus positive 8 gives me 6y. Equals, adding down, negative 12 plus negative 24 gives me negative 36. Quick some division here. Y equals negative 6. Now, it seems fast, but we still got to find that x. So I'm just going to take my top equation here and plug in my y to figure out what x is. So, my final solution, x comma y, 6 is x, negative 6 is my y. At this point, I would suggest pausing the video and working through numbers 1 through 4 and then checking your answers at the bottom. These will all follow that setup where something's going to cancel almost immediately. Once you've done so, we'll move on to 5. Now, here, you can notice in these next 4 problems, we don't have any of those nice cancellations like you had in 1 through 4. So we got to do a little bit of work. So, let's look here. Well, these are different numbers, they're both negative. So that's going to be a little more work to cancel those. We'll see that later on. But if I look at my y column here, well, they're the same exact number, but I need to make one positive since they're both negative. If they were both positive, I'd need to make one negative. So here, to get my positive, I'm just going to multiply the second equation. You could do it to the first, it doesn't make a difference. But to change my second equation up here, I'm going to multiply everything by negative 1. So that negative 1 goes to each and every term. So that gives me the equation, negative 1 times this gives me 4x plus 9y equals positive 23. So that's the distributing there. Now I got a positive 9y and a negative. So I'm just going to go ahead and copy this equation down. It doesn't matter which one's on top or bottom. Now at this point, I have that set up. So I got positive 9, negative 9y. So I can add and I know they'll cancel out. So these terms cancel, which means I add down these. So 4x plus negative 2 gives me 2x. And it's equal to, if I add negative 2, dividing by 2 on both sides, I'll get x is just negative 1. Now, let's use my top equation again to plug back in and find y. So I'm substituting x as negative 1. Y equals positive 3. And my x was negative 1, so my answer, negative 1, positive 3. You'll notice that similar step there of multiplying one of the equations by negative 1 will work for each of these next 4 problems. So again, pause the video at this time, work through 6, 7, and 8, check your work with the bottom answer key before you move on. From here, we'll move on down. So let's take a look now at number 9. Alright, so amping it up a bit here. For 9 through 12, these are going to be a little more complicated. So, right now I'm looking, I don't have any terms that are the same, not one positive, one negative, so we're going to do a little bit more work here. So what we're going to do is when you're given a situation like this where we can't do any of the methods we've done above, we're always going to look to cancel x. So, I'm looking at my x's. I got 5x and 10x. So, the way to cancel these, I'm going to multiply the top by what's in front of the x here. So, I'm going to multiply everything here by 10. So, that gives me 50x plus 10y equals 90. On the bottom, now, since they're both positive, I know I'm going to need a negative. If one was already negative, one of these x's, like for example, here, then we wouldn't have to do this because one's already positive and one's already negative. But here, since I have both positives, I know I'm going to need a negative. So now on the bottom, I'm going to multiply by what's out front of the x. But I'm going to throw a negative in there so I can cancel and distribute to everything. So this gives me negative 50x plus 35y is equal to 90. So once we've done that, now we can start solving. So here's where we'd have to do that twice. So multiplying top and bottom. So this is the most complicated version of these problems. So here we're always going to cancel x's by this method. So these positive 50, negative 50, they go away. Adding down, I get 45y is equal to 90 plus 90 is 180. Dividing by 45, I'll get y is equal to 4. Now, we're going to plug back in. I would suggest using the original equations. You can use any of those on there, but the originals tend to have smaller numbers. So I'm going to use that 5x. I'm going to substitute, so plus 4 equals 9. X minus 4 from both sides. So 5x is equal to 5. Divide. X is equal to 1. So my final answer here, x comma y, is 1 comma 4. So, once you've gotten through this, complete problems 10, 11, and 12. If you need help, make sure you're asking questions and referencing these notes. Once you've done that, check your answers with the key at the bottom, and we're going to move on to 10. So 10, we're going to work on these first 4 problems together. You'll then complete the rest for homework, as well as number 11 for homework with all of these 5 problems. So we'll do a few together, and then you'll have a good chunk to practice on your own. But as far as our notes go, let's go ahead and take a look here. So break-even word problems. Essentially what this means is we're going to have something like one equation equal to another. Alright, so number 1, you decide to market your own custom backpacks. You invest $8,050 for a printing machine and spend $275 to buy and print each backpack. If the backpack sells for $10.50, how many backpacks must you sell to break even? So we're going to think about 2 sides of an equation here, our costs and setting it equal to our profits. That's what the idea of break even means. How many do I have to sell so that I'm starting to make money? So on my cost side, well, I invested $8,050, so that's a cost. And then it's saying I spend $275 for each backpack. So plus $275, remember that each and every, that means we get an X by it. It's equal to, I'm selling each backpack for $10.50. So that $10.50 also gets an X. From there we solve. So I'm going to subtract. So 10.50 minus 2.75 gives me 775x dividing gives me 1038.71. Well, I can't sell 0.71 of a backpack, so the answer we'd be looking for here is we're going to round up to the nearest whole number, because that's how many backpacks I sell, because I can't sell a fraction one. So we're always going to round up in these break-even problems. Now, number 2. Chad and Stacy invest $3,600 in equipment to make dog collars. Each collar costs $5.25 to stitch and sells for $12.37. So things that are costing me money, if I'm investing it, it's over here. And it's $5.25 for each, so that gets an X. Equal to, I'm selling them for $12.37 each. Solving. Dividing. I'll get X equals 505.62. So again, we always round up in these problems. So I need to sell 506. Moving down. At the local ballpark, the team charges $12 for every ticket and expects to make $3,200 in concessions. So that looks like I'm charging $12 for each ticket, so that's X, and I'm going to make an additional $3,200. I have to pay my players, so on the other side here, I'm paying them $7,500. And all other workers get another $2,000, so it's another $2,000 I'm spending. And lastly, each fan gets a free bat that costs me $5 per bat. So since it's per bat, that gets an X. So a little more work here, but we're solving the same kind of way. So there's nothing I can combine over here, so that's just going to come down as 12x plus 3200. Over here I can combine my numbers. If, say, we solve this one to the left, again, you know it doesn't matter which way we go. Subtracting over here to isolate my x. That would give me 7x is equal to, and dividing, I'd get x is 900. So this one came out to a nice whole number, so no need to round. So there, we need to sell 900 tickets just to break even. If I sold more than that, it would be a profit. And our last example, before you guys get on to practicing here, at the local movie theater, the owner charges 10 for each ticket, and I'm going to make about 1,200 in popcorn sales. So that's equal to 10x plus 1,200. The owner must pay her ticket takers $2,700 and all other workers $500. So now I'm spending money. Each customer gets a free medium drink that costs me $4 per drink. So, same as above, let's go ahead and solve now. So that gives me 6x is equal to 2,000 divided by 6. We get x is 333.33. So again, we always round up. So I'm going to need to sell 334 tickets. You'll notice the examples and other problems line up very closely, so please complete those now. And again, when you're done with that, go on to 11. Again, very similar examples. Once you've completed that, move on to 12 for some more notes. Alright, so looking at 12 here. Here we're dealing with inequalities. So, greater than, less than, or equal to. That's when we get the line underneath. These use a solid line, which will make sense once we graph a few. These two, without the or equal to, use the dashed line. Essentially, it'll get into helping us determine which values actually satisfy these. So, first thing we're going to do is we're going to notice that these are graphed almost identical to our standard graphing equations, with the only difference being is that solid or dashed line and our shading. So, if I'm going to graph my first line, let's do that in red. So here I have, pretend this is an equal sign. So my m here, the number out front of the x, that's just 1 over 1. And again, if you're looking for a review on graphing, go head back to Unit 6 videos. My b here, positive 2. So I'm at positive 2, and my slope positive means up 1 over 1, so up 1, right 1. Now, before you draw the line in, because this doesn't have that line underneath, we're actually going to draw this in with a dashed line. So let's go ahead here and draw it in with a dashed line. And for these, we can just use 2 points to graph. You'll understand why shortly. For our next one, I'm going to do this one in blue. It's already solved for y, so we can identify m and b rather quickly. Here it's negative 2 over 1, and b is negative 1. So I'm going to go down here to negative 1, and then negative 2 means go down 2, positive 1, right 1. So down 2, right 1. Now this one has the line underneath, so that means this one gets to be a solid line. Now, the way of identifying solutions involves shading. So, some notes on this. If we want to go ahead and shade these, I'm going to give you guys a bit of a shortcut. So, if it's greater than or greater than or equal to, these we're going to shade above the line. If it's less than or equal to, you guessed it, we shade below. So, let's look at our red equation here. This one is a greater than. So I'm going to shade above this line. If you think about above, that would be the top chunk here. So I'm going to shade here and here. If you look, every time we graph noise, we're going to get 1. So let's take a minute here. I have 1, 2, 3, 4. Kind of chunks of the graph. So rather than shade, let's just go ahead and like kind of mark them. So I'm in this section here, so I'm going to kind of just draw a nice little, let's go to star. So I'm either here or here, because I'm above that red line. So now I'm in this part. Now for the blue line, it's a less than, so we're shading below the line. So the two chunks below the line are here and here. Now the final part where we're actually going to shade is the part that contains both solutions. So the part that would contain both solutions here would be where I have both my stars. So this chunk is where my solutions are. That means any point in here I could plug in, and it makes those inequalities true. Let's move on to number 2. So remember here, since I don't add anything at the end, that's like adding 0. So here my m is just 2 over 1. My b is 0. So graphing means up to right 1. I look, it's got a line there, so that tells me it's a solid line. And the next equation again. This one now, it doesn't even have an x, so that's a special case again where we had that horizontal line. So it's a horizontal line going through -1, and it's solid because it's got the line underneath. So that's this line here. And again, for a review of this, in Unit 6, there's an entire lesson on special case graphing. Alright, so let's look at our red line first here and think about where we're going to shade. So this one's greater than or equal to. So that means I'm shading above. So the top of this red line involves here and here. For my blue line, it's greater than or equal to, so above the blue line would be here and here. We see rather quickly which section has both of those stars. So this is our final shading for all the solutions that make this true. Our last example, a bit more work. So as you remember, we can only graph when it's like y equals mx plus b. So here, I'm going to have to get y by itself. So I'm going to subtract x from each side, which gives me y is less than negative 1x plus 5. So going to graph here, we know that m is that -1 over 1, and my b is positive 5. So I'm at 5, down 1, right 1. Since it's just less than, this one gets a dashed line. Now for our blue line. Well, here it's already solved for y, so m is just 1 over 1, b is -4. It's or equals to, so it's a solid line. So here, if we're looking at our 4 parts of this graph, let's go ahead and highlight these just for further recognition. So in this example, we need to kind of look at where these 4 areas are. If we look, every time we get these lines, it's forming some kind of cross, just at different perspectives. So if I look where they're crossing at, well, it looks like I have a little area here, and then the cross on the top, well, I got this chunk of my graph. Well, here to the left, I have this whole region. Again, it doesn't matter on the size of the region. That doesn't necessarily tell us what our answer is. We're just going to visualize where these 4 sections are. And our last one, kind of below the cross, would be down here. So that's a quick way to determine where those 4 regions are. You're looking from our intersection, up, left, right, and down. And again, it may be at various kind of perspectives, but that's the general pattern. So I'm going to go ahead and erase those shading now. So we can go ahead and figure out which one is the correct one for our solution. Alright, so looking at the red line, right? We got a less than, so I'm going below the red line. So that means I'm either here or here. Our blue line, That's a greater than. So that means I'm above the blue line. So that's here or here. We can quickly see this is the section of our graph that contains both of those stars. So that's where we shade. And again, just because it's the biggest doesn't necessarily mean it's right, but in this case it happened to be true. Once you've done that, I would like you to complete the next 3 problems, as well as move on to 13. You'll be working on the highlighted problems here, so all 6 of them. When you've completed that, be sure to check your work, and then you can move on for your next section of notes in 14. So, number 14 here is a little bit of a different method of how to go ahead and check these, but I think you'll find that the shading works great the way I showed in the last lesson. If you are totally struggling with that, what I would like you to do is raise your hand. Come up to my desk when you're called upon, and I can show you a couple of these examples together. But, assuming you already kind of got what's going on, you can skip over this section for now. If you'd like the practice, you may go ahead and complete these problems. Even just 1 through 4 would be great. The rest here involve a little bit more work. However, again, if you are struggling with the methods shown in 12 and furthered upon in 13, this I would be happy to show you another way to solve them. So, going from here, we're going to move on to 15. So again, all of 14 is essentially, if you're struggling with 12 and 13, raise your hand, I call on you, you come up to the desk, we go through 14 together. So a different method of testing and shading those inequalities. But if you're feeling good, you're feeling confident on 12 and 13, you can skip 14. It's up to you. 15, we're going to do 2 of these together. So we're going to go ahead and work through problems 1 and problems 2 together. So a bit of a word problem with inequalities. Once these are completed, you will finish 3, 4, 5, and 6 as practice. This will be the way in which you best prepare for your final exam. For this unit. Sorry. Unit 8 exam, not final exam. So once we get through this, you'll finish up 15, and then jump on to your review. But, let's finish up our last bit of notes here for this unit together. Okay, so for problem 1. As a fundraiser for your soccer team, you must raise at least, that's going to be a key word there, $30 by selling cookies for 2 a box and donuts for 5 per box. You must sell more than 10 boxes. Okay, so first thing we're going to do is define our variables. So again, this is kind of similar to what we did back in Unit 7. We're selling 2 things. So it looks like I'm selling cookies and I'm selling donuts. So let's let X be cookies and Y be donuts. So similar with those XY problems we see in Unit 7, so if you had not completed that, it'd be great to go back there and look for those kind of standard form problems. So we got cookies and donuts. Now, for this first inequality, I'm looking at this sentence. Okay, so I'm selling cookies for $2 per box, so that's 2x, and I'm selling donuts for 5, so it's plus 5y. Now, if I want to make at least $30, that means I want to make greater than or equal to $30. So that would be greater than or equal to 30. Now, for the second inequality, I'm going to look here. You must sell more than 10 boxes. So cookies and donuts, that's the number of boxes of each. So if I need to sell more than 10, well, that means that x plus y must be greater than or equal, must be strictly greater than 10. Here it's at least, so it's greater than or equal to. Here it's strictly more than, so that means greater than 10. Now, with this too, we're going to graph using what's known as intercepts. But a way that I find a tad bit easier here, so we're going to go ahead and plug these things in. Now, some notes on using intercepts. So let's take these off to the side here. To find our x-intercept, we ignore the term y. So even if there's a number in front, we just basically pretend it's not there. To find our y-intercept, we ignore the term x. So again, no matter what's out front, we pretend it's not there. So let's look at our first inequality here. So I'm going to do this one in green. So for my green one here, I have 2x plus 5y. And when we solve these, we can go ahead here and just pretend it's equal to. That's how we find intercepts. So first, I'm going to find my x-intercept. And then over here, I'm going to do some extra work to find my y-intercept. So here, when I want to find my x-intercept, we are going to ignore our y term. So that's ignoring that 5y. Similarly here, to find my y-intercept, I ignore x, so I'm going to ignore 2x. So if I ignore this 5y over here, that gives me 2x is equal to 30. Divide by 2. So my x-intercept is at 15. Here, if I ignore the 2x, that gives me 5y is equal to 30. That gives me a y-intercept of 6. So for first inequality, my x-intercept, 15. My y-intercept, 6. Take a minute now and make sure you have that all down. I'm going to erase to do the next inequality. Okay, actually we won't erase, let's kind of do some work down here. Alright, so I'm going to do my next one in red. So I know I'm going to have two parts to this thing, so I'm going to write my equation twice. I got x plus y is equal to 10. So again, when we find intercepts, we always treat these as just equal signs. So for my x-intercept, here it's just y, but I'm still going to ignore it, so I ignore my y. For my y-intercept, it's just x, but I still just ignore it. So that gives me, well, y is equal to 10. In this one, if I ignore x, oops, backwards here, we're ignoring y. So that gives me my x-intercept, since it's just x equals 10, it's just 10. Here, when I ignore the x, I get y is equal to 10. So my y-intercept here is also just 10. So for both of these, 10 and 10. Alright, now we're going to use those to graph. Now the reason we're only looking at the first quadrant here where everything's positive is because we're dealing with strictly real-world things. So these, in most cases, we're only going to look at positive numbers. So let's go ahead here. Looks like 15 is my biggest, so I could probably just label these by ones. So let's go ahead and label everything by ones. And since I don't quite have enough, I'm just going to kind of extend that up a bit and throw a 15 on there. Another option is you can use a different scale. So say you want it to go by 2s. As long as you label it, you can use whatever scale you want. Example 2 here, we'll write the inequalities, but we'll leave the rest up to you to do. So we'll go ahead and go through the inequalities here, but as far as the rest of the problem, that'll be left to practice. Okay, so now I'm going to graph my two inequalities. So let's start with my green one. Here I have an x-intercept of 15. So I'm here at 15, and a y-intercept of 6. So now I'm on the y-axis at 6. This is an or equal to equality. So what that means is I have that solid line. For my red equation, I have an x-intercept of 10, and a y-intercept of 10. It's just strictly greater than. So what that means is that's a dashed line. Now for the shading. So to figure out where my solutions to this are, well, let's take a look here. So my green is a greater than or equal to. So that means I want above the green line. So that would be this section and this larger one here. Sorry. So for our red, we have a greater than as well. So going above the red line puts me here. Oops, should probably put that in red. So above it would be here and here. We see that this is the portion of our graph that contains both. So our solution set, where we would shade, would be this whole upper region here. Now, let's work with this situation. Well, the following combinations work for this. 25 boxes of cookies, 20 boxes of donuts. So we let cookies be our x. So this axis here represents our cookies. Y was our donuts, so this vertical axis represents our donuts. So the number of each in boxes sold. So 25 boxes of cookies. So that's way over here somewhere. And 20 boxes of donuts. Well, that looks like it's going to be way up here. But let's go ahead and check. So I want to see if it satisfies both of these. Again, we can see that if we plug in the point 25, 20, well, it's going to be way up here somewhere. So that's definitely in the shaded region. So the answer is yes. Oh, 10 boxes of cookies, 5 boxes. So let's see, 10, 5. Yeah, that's definitely in there too. So that's another yes. 6 and 2. Well, 6 boxes of cookies, 2. That is not in that shaded region. So the answer there is just no. For number 2 here, we'll just go ahead and write these inequalities, and at that point, the rest of this will become practice. Alright, so we have Frank works 2 jobs. He makes 6 per hour working with his dad, and 14 per hour doing yard work. So the 2 items here, we'll call this working with dad for X, and 14 for doing yard work. So that'll be yard work. And again, it's the hours of each. In 1 week, he needs to make at least $84, and he only has time to work a maximum of 10. So let's think about equality 1 as how much we're making. Well, I get 6 per hour for dad, plus 14 per hour, so Y for yard work, and I need to make at least 84. So that's going to be greater than or equal to 84. For the next one, I only can work up for a maximum of 10 hours. So that means that X plus Y has to be less than or equal to, because it says I can work 10. So we'll use that same strategy here of the red and green to find our intercepts. So for these two, we'll find our X here and our Y here. So for my X-intercept, I ignore the Y. So I get 6X is equal to 84. For my Y-intercept, I ignore the X. So I get 14Y is equal to 84. Kind of solving both of these here. So here my X-intercept would be 14. And my Y-intercept here would be 6. Now working with our green one, or our second equation. For our X-intercept and our Y-intercept. For X, we ignore the Y, so I just get X is equal to 10. So that's just going to be 10. Here for my Y, I ignore the X, so I end up with Y is equal to 10. So my Y-intercept is also just 10. Alright, so now we're going all the way up to 14. So again, they'll fit on this one, and say they didn't. Say you had like 25 as a point, just count by 2s. But let's go ahead and this one and just go by 1s. Okay, so before we graph, let's go ahead and label these axes. So x, my x-axis here, this is working with dad. That's how many hours I'm doing that. So hours working with dad. Y is my yard work, so it's hours of yard work. Alright, now let's go ahead and graph. So my red line here, x-intercept of 14, y-intercept of 6. It's an or equals to, so that's a solid line. For my green, 10 and 10. It's also an or equal to, so that too would be a solid line. Now, before we can start answering questions, let's shade. So the red one was a greater than or equal to, so I'm shading above the red line, so that'd be here and here. The green is less than, so I'm looking below. So below the green line would be here and here. We check and see that the sweet spot where this scenario works out is right in this shaded region where we have both of our stars. So in your case, instead of using both stars, since you may or may not have two colored pens, maybe do the first one as a star, the second one as a square, as a circle. Whatever works for you. Alright, so answering these questions. Describe a potential combination of hours so that this is satisfied. What that means is let's find something in the shaded region. I would suggest not picking something like right on the lines just to make sure. So if I look here, well, 2 and 7. Or we could do 1, 7. That's definitely in there, right? So let's use 1 for my x, so that would probably be 1, 7 for my y. For this one, which one should he work so he can maximize his income? Well, yard work pays more, so quit working with dad. And why? Because yard work pays more. Alright, from there, you guys are finishing the rest of these problems. Once you've done that, you can go ahead on to the review. When you've completed the review, the last thing you have to do to successfully get through this unit would be pass the Unit 8 exam. Best of luck. Make sure you're checking, raising that hand, and asking for help if you need it.